All right, here comes the video for 4.7. If you look at the title here on the screen, you can see that it is inverse trig functions, which we have already talked about. But we're going to look at them a little differently here and deal with some other issues that come up. So you can see right here, these are the filled in notes, which we'll just kind of be going through some of. Here's the graph of the sine function. Now, when you make an inverse function, the way we start is actually by, well, if this, why I'm pointing it with my finger, this is y equals sine x. So you turn the two variables around and make x equals sine y, and then you solve for y. And when you do that, we get that formula that we've dealt with a lot, y equals the inverse sine of x, all right? Now, if you graph that thing, though, what happens is that if you take any function and you graph its inverse, you flip it along a diagonal line, the diagonal line at 45 degrees. And so, well, we started here with our nice little sine wave that goes down the, does its wave down the x-axis. When you do the inverse, you get the wave going up the y-axis instead, and you get that picture that's down below. All right. But the problem with that is, maybe you remember from previous math courses, is that that's not the graph of a function. For a function, we want to plug in one number and get one number out. And one way to check to see if your graph is the graph of a function is the vertical line test, and this guy fails it like crazy. All right. So this graph over here, obviously, if you draw, there are lots of vertical lines that cut through this graph in more than one spot. And the graph of a function, a vertical line should only pass through once, if at all. So this is not the graph of a function, but we use inverse trig functions, right? When you put a number into your calculator and do inverse sine, it doesn't give you a huge list of answers, it gives you one answer. So to make this the graph of a function, what we do is erase a whole lot of it. And in fact, we get rid of everything but what's pictured down here. All right, this is the graph of the function, the inverse sine function instead. And this this portion of the graph corresponds with what we talked about before with the inverse sine function. We mentioned before, like when we were solving triangles, that if you do inverse sine of a number, it only gives you an angle that's in the first quadrant from 0 to 90 degrees. Now, if you put in a negative number, it could give you a negative angle from 0 to negative 90 degrees. And that's what this graph is showing. Now, it's in radians, but if you put in a number, it gives you a y-coordinate that is between minus pi over 2 and pi over 2, or in other words, negative 90 degrees and 90 degrees. All right, there's other spots on the graph that x-coordinate could correspond to, but the inverse sine function only gives you an answer in this little range here. All right. So, and this paragraph kind of says a lot of what I just said here too. So this is a function. What we call the domain, the legit inputs for this function only go from -1 to 1. All right, this graph doesn't extend beyond that. You can't put a 2 into the inverse sine function, or you can try and your calculator will complain at you. So you got to put in a number between -1 and 1, and what comes out is only between -90 and 90, minus pi over 2 and pi over 2 in radians. So in other words, the domain, the numbers you can plug in, go from -1 to 1. The range, which are the different outputs of the function, from minus pi over 2 to pi over 2. All right. So, and that completely matches up with stuff we talked about before, too, in terms of these functions. Now, inverse cosine, what we talked about before, is that if you do inverse cosine on your calculator, you only get angles between 0 and 180 degrees, or in terms of radians, 0 and pi. All right. Oh, and I forgot example 1 was coming up here. Yeah, so we'll just glance at it. All right. So these blanks, which you can see are already filled in, you could do without a calculator. We're getting answers in radians, and they're all asking, all right, this is inverse sine now. What is the angle whose sine is 0? Well, that is 0 radians or degrees. all right, which is why that's equal to 0. Inverse sine of square root of 3 over 2, what's the angle whose sine is square root of 3 over 2? Well, if you look at a unit circle or try it on your calculator in degree mode, it'll say 60 degrees. That is pi over 3 in radians. Now, the tough part about radians is that those your calculator won't actually say pi over 3. It'll give you the decimal version of that number, and it'd be hard to remember all the different decimal versions for our different angles in radians. So you could do it in degree mode and convert to radians, or look at a unit circle and pick out which angle. Now, between negative 90 and 90 has a sine equal to square root of 3 over 2, 60 degrees, or in radians, pi over 3. How about of minus 1? What's the angle whose sine is negative 1? Well, in the range for this function, it's negative 90 degrees, or negative pi over 2. And for negative square root of 2 over 2, you get negative 45, or in radians, minus pi over 4. All right, now back to cosine. We have to do the same sort of thing with cosine. If you graph x equals cosine y, you get a long wave that goes up and down the y-axis. So to make a function out of that, we got to erase most of it. And what we choose to keep is this much. Now again, in terms of x-coordinates, it goes from minus 1 to 1. The numbers that come out, the y-coordinates, go from 0 up to pi, 0 to 180 degrees, like we talked about before. All right, and so there's our domain and there's our range. So examples number 2, you could give those a try on your own, but I'm going to go over them here in just a sec, but it's the same concept as up here with example 1. What's the angle whose cosine is? Fill in the blank. All right, so if you want to go do them a sec, pause the video and try them out, and I'm just going to go down and go over them. So here's what we get for answers. Inverse cosine of 0, the angle whose cosine is 0, between 0 and 180 degrees is 90 degrees, pi over 2 in radians. Square root of 3 over 2 is 30 degrees, that's pi over 6. Negative 1 gets you pi, or 80 degrees. And negative square root of 2 over 2 is at 135 degrees, which is 3 pi over 4 in radians. All right, inverse tangent. So the graph of tangent, if you remember, is just one after another of these little wiggly lines that go infinitely up and infinitely down. So when you graph x equals tangent y, you get these layers here, which also fails the vertical line test like crazy. All right, so again, we get rid of a lot of it and just look at the middle one here that goes through the origin. That's the one that is the graph of inverse tangent. All right, now it doesn't have restrictions on the domain. You can do inverse tangent of any number. The output, though, like inverse sine, is just between minus 90 and 90, or minus pi over 2 and pi over 2. So there's that graph of inverse tangent, just this much. All right, if you want to pause and try the inverse tangent examples, in example 3, do that. All right, down to look at them now. Again, it's just asking these questions. What's the angle whose tangent is such and such? Well, 0, it's 0 degrees or radians. 1 is 45 degrees or pi over 4. Here's minus 1 with negative 45 degrees or negative pi over 4. Square root of 3 is actually 60 degrees, or in other words, pi over 3. Now, the inverse tangent notation that we use, we had to be clear that when we write tan and we put that minus 1 up there, or do the similar thing for sine and cosine, that we are not talking about reciprocals here, even though a negative 1 as an exponent means reciprocal. But since that can be confusing, there's a different name for the inverse trig functions that is more commonly used in calculus especially, and that is to put the word arc in front of it. So here is that other notation. Rather than sine inverse, cosine inverse, tangent inverse, These functions are called arcsine, arccosine, and arctangent. All right? Arctan is particularly important when it comes to calculus. So computing these guys, maybe you actually have an arctan function like stated that way in your calculator, but otherwise when you see arctan, you need to know that means do inverse tangent. And so if you put your calculator in radian mode and punch these guys out underneath, you can try them a sec if you want. The answers are laid out right there. All right, noting that one of them doesn't exist because negative 1.6 is outside the domain of arcsine or the domain of inverse sine. There's no angle whose sine is negative 1.6. That's why your calculator will complain at you, and yeah, we get it does not exist. All right. A few more examples here to finish up this section, and then these inverse functions will be used even more to solve equations in Chapter 6, which is where we're going after this section. A function and its inverse are supposed to do the reverse of each other, right? Just like squaring and taking a square root are inverse functions. Adding 3 and subtracting 3 are inverse functions. So these guys, so taking a tangent of an angle and then doing the inverse tangent of that result should get you back to where you are with some restrictions here based on these domain and range issues that these functions have. So let's just go down through these guys. You know what? I'm just gonna open up the non-filled in version for these. So 4.7. Okay, so all of these guys right here. And now you can see the filled in versions. I'm not going to write on this PDF. I will just talk through them here. So cosine of the inverse cosine of a half. So the inverse cosine of a half is an angle whose cosine is 1/2. Now in particular, if you did that on your calculator, it would say 60 degrees, or pi over 3 if you're in radians. But the whole point of the result is that it's the angle whose cosine is 1/2. So if you take the cosine of an angle whose cosine is 1/2, you get 1/2. That's kind of the point. All right, this is, again, inside the parentheses, the result is an angle whose cosine is 1/2. And then we take the cosine of that thing and get 1/2 back again. All right? So the next one, inverse tangent of 21. I do not know what that angle is in degrees or radians, but I do know that if you take the tangent of that angle, this angle has the property that its tangent is 21. And the tangent of that angle then is 21. All right, same sort of deal here. Inverse sine of 0.8 is some angle, but it's an angle whose sine is 0.8. So when you take the sine of that angle, sure enough, you get 0.8. Okay. Now, turning these guys around a little bit. One little tricky thing kind of pops up here. Sine of 10 degrees, all right, is some number. Your calculator can tell you what it is. The inverse sine of the sine of 10 degrees, so inverse sine is trying to give you the angle whose sine is the sine of 10 degrees. It starts to be hard to almost understand the words because you feel like you're just repeating yourself. But yeah, we're trying to say two things that kind of cancel each other out. All right, so the sine of 10 degrees is some number. The inverse sine gives you the angle whose sine is that number. Well, the whole point is that number came from the sine of 10 degrees. So yeah, you get 10 degrees. Inverse cosine of the cosine of 150. Well, cosine of 150 is something, but the inverse cosine gives you the angle whose cosine is that number. And, well, that's 150 degrees. And so that's what you get. Which makes you feel like the last three are going to just go by lickety-split, but here's where the little twist comes in. 10 is in the range of the inverse sine function. Remember, inverse sine gives you angles between minus 90 and 90. Cosine gives you angles between 0 and 180. So inverse sine of sine of 150. Well, sine of 150 is some number. The inverse sine gives you the angle whose sine is that number. But 150 is not in the range of inverse sine. It doesn't give you that angle. It will give you an angle, but it'll give you a different angle that has the same value for the sine function as 150 does. Right? And maybe there you need to actually, I'm going to bump up my dot camera. Ooh, that's perfect. So here's 150 degrees. And if this is the unit circle, here's some x and some y, and sine is the y coordinate. Now, when you put in a legit y coordinate and you ask inverse sine to give you the angle that goes with that y coordinate, well, then it doesn't give you this angle. It gives you an angle somewhere in here. So we need the angle that has the same sine value as 150, or in other words, has the same y coordinate on the unit circle as 150. Well, this y coordinate, well, this point over here also has the same y coordinate, and you get a nice little symmetric picture here. So in fact, okay, yes, this is 150. Well, what is this? Well, these two guys have the same reference angle. This is 30 degrees, which means so is this. So this problem here, where'd it go? Inverse sine of sine of 150 is not 150, it's 30. All right, the next two, if you want to try them first on your own, go ahead. Cosine of 300. I think drawing a picture of these guys helps. So 300 is right down here. Here's our unit circle, and cosine comes from the x-coordinate. And this corresponds to this x-coordinate. But when you do inverse cosine, it doesn't give you an angle in quadrant 4. It gives you angles from quadrants 1 and 2. So what angle has the same x-coordinate as this guy? Now, if you follow this up, we get this angle right here. Nice symmetric reflection over the x-axis. And if you work out the angles, this ends up being 60. So the cosine of 300 is some number. It's 1/2 actually. Inverse cosine of 1/2, though, doesn't give you 300 degrees. It gives you the angle but in quadrants 1 or 2, whose cosine is that number. Inverse cosine of 1/2 gives you 60. 300 is just in the same reference angle family. So to some extent, when you do these, the one way to think about it is, well, if it's not going to give me that angle right back, because that angle's not in the range of that function, it will give me the angle in the same reference angle family that has the same value for tangent or cosine or whatever. So, inverse tangent of tangent of 225. Well, 225 is in quadrant 3. It's right there. Here's 225. Quadrant 3 tangent is positive, and this guy has a reference angle of 45 degrees. But inverse tangent of whatever this number of tangent 225 is not going to be 225, because inverse tangent gives you stuff from quadrants 1 and 4. And quadrant 1 is the other quadrant where tangent is positive, so it's going to give you the angle in that quadrant with the same reference angle, which is 45 degrees. So, just to recap, inverse sine of sine 150 is 30. Inverse cosine of cosine 300 is 60. Inverse tangent of tangent of 225 is 45. The first two, in which the inverse came second, basically, actually worked out because 10 and 150 are in the range of those inverse trig functions, but that was not the case down here. Okay, so we're kind of emphasizing again, the fact that there are lots of angles around the unit circle that have the same values for sine and cosine and tangent, maybe differing by a minus sign. But the inverse trig functions don't give you all of them. They only give you one, and you need to take reference angles and go from there to figure out other solutions. And that's what we'll see more of in Chapter 6. And that's what will come up in the next video then.